Hello, we will start recording doing the third practical, that is to subtract R5 R4 pair from R7 R6 pair and store the result lower byte in 35 ice and 36 ice, the higher byte. So we have two pair of uh, numbers. This is R4 and R5 and R6 and R7. Let's take R4 as the lower byte and R6 as the lower byte of the pair. R7 and R5 are the higher bytes. So we cannot subtract 2 bytes at one time or 3 bytes at one time. The only instruction to subtract in 8085 is to subtract 8 bits or 1 byte. So we have to do one after another. R4 subtracted from R6 and R5 subtracted from R7. So we have to do it separately, so that's what I'm saying. So this is step 1. Sorry, this is step 2. This should be step 1. Okay, so it is clear. We cannot subtract directly the content of one register from another register, so one of the numbers should be in the accumulator. So what should be transferred is R6. So R6 we transfer it, the first step, then we subtract it. Then after that to do this next one, we have to clear it. We have to clear the accumulator. So we transfer to R35, sorry, to the memory location 35 from accumulator. So the first part is finished. If there is a borrow in this one, we have the facility. So the borrow is always subtracted in the next step. So you can see over here, next step is this. Also we have to change. This is R4, step 4, and this should be step 5. So step 4, we have to transfer R7 to A. Then we subtract the content of R5 from A. And then we transfer to where what is asked in the question, that the higher byte should be transferred to 36 ice. So we transfer it. So the content of A is transferred to 36 ice. So this becomes the higher byte. But we have two cases. So as we are dealing with the hexadecimal number, we have to know something about the hexadecimal number and how it's subtracted. In the normal function, if all the numbers are, we are going to separate the lower byte and the higher byte separately, we have to do it. You can see when the first number, that is the subtrahend, is bigger than the second number, the median, there is no problem. You can directly subtract it and you get the answer. So this is the binary one. So how it is subtracted, you can do it. And if you know how to subtract in the hexadecimal number, no problem, you have to try. Okay. So 1 carry means in hexadecimal number, how much is added to the number? In normal addition, if 1 carry means we add 10. So over here, when the number is smaller, then what happened? You can see it became very difficult. So 1 is smaller, so 1 is carried here, and what do we get? Decimal representation of 17. 1 in hexadecimal is 17. So if you subtract it, 17 minus 4, that is how much? 13. 13 is nothing but D. So like this you can subtract or you can subtract it over here and change it to hexadecimal number. Okay, so the answer will come out like this. So let's see this second two case whether it is correct or not. So the first number R6 we transfer to A, we subtract it, and we transfer to 36A. 36 is according to the question. 36 is the lower. Okay, here is a problem. 35 is the lower byte, so we have to transfer over here 35. 35. Then 36 is the. So second part, we again transfer R7 to A, R5 is subtracted from A, and the result is moved to 36. So let's see over here. I think it is wrong. So assemble. So here it should be 35, and here according to the question it is 36. No problem. So we have written everything, and you can see we have PSW. Let's see this status. PSW is the program status word where all the bits represent something. So where carry is represented in the last one, the 8 bit, the highest 8 bit over here it will. So let's see, let's assemble it. No error. Let's simulate it. So you can see when we start simulating, PSW is all 0. Okay, so carry bit will be here if there is a carry bit, borrow bit, carry in terms of addition and borrow in terms of subtraction. So if it is borrowed or carried, 1 will be displayed over here. So let's move R6. So what was our data? Let's put our data. What is R5? Let's see again. Let's do the first one, 22, 20, R4, R5, R4, R5, 11, 33, then 22, 44. So R4 is 11 ice, 22 ice, then 33 ice, 44 ice. Am I correct with the data? No, 3311, sorry. So it should be 33 ice, 11, then here is 22 ice, 11. So this is the data from 42, 22. We are going to subtract 33, 11. So that was the first example, case 1, 42, 22, 33, 11. We are subtracting and we get 1, 1, 1, 1. So let's see. So 22 is moved from R6, 22 is moved and it is subtracted, 11 is subtracted. So we got 11 and we move to 35 ice. So 35 ice. So hexadecimal you change it. This also we'll see the result. Okay. So 11 we got it, and now again 44 is transfer and we subtract 33, we got 11 transfer to 36 ice. So 11 1 1 1 1 we got it. So the first part is finished, first case. Now second case, 22 11 is, we are going to subtract 33 44 this number from 22 11. So let's now restart, but let's change first. So what is this? 44 ice, enter, and here 33 is same, and here 11 ice, enter, and then what, 22 ice, enter. Okay, now let's see, simulate. So let's see the answer, EECD. So it should come. So we can put it over here. What was the answer? Okay, let's put it over here so that CD ice. So 0 CD ice hexadecimal, then this is 0 EE ice, because we cannot start with the alphabet. Before alphabet we have to put 0. So this is EECD is the answer. Let's see. So subtract, we transfer 11, and from 11 we are going to subtract 44. Yes, CD is coming, so we will transfer over here CD. Then next 22, and we are going to subtract 44. You can see still the carry is there from the previous subtraction. Okay, so because of this carry borrowed, it will be utilized in this subtraction, in the second part. You see this portion, PSW, the last bit, the flag is set. So EE, and the answer is EECD, which is our answer because of the calculation. So this is how we do the practical. You can practice it, and I will be uploading more.